All right, welcome. Today we are diving into something huge, one of humanity's most incredible and ambitious goals, astro-engineering. Yeah, we're talking about the actual science and strategy of building our future, not down here on Earth, but out there, in the final frontier.
It all boils down to this one question, doesn't it? It's the question that's fueled so much science fiction and, the dreams of astronomers for generations. But here's the thing, it's not just a dream anymore. It's a real-world engineering problem that people are trying to solve right now. So the question is, how do we actually do it? How do we build a permanent home among the stars?
I love this phrase from our source material because it just perfectly captures the massive scale of what we're talking about. This isn't about quick visits or just planting a flag. The key word here is permanence. It's all about designing the real, nuts and bolts infrastructure for a future where humanity is a true multi-planetary species.
So to really get our heads around this, we first need to understand what this new celestial frontier, this, huge expanse of space beyond our planet, really is. And from there, we can define the grand quest we're setting out on.
At its very core, astro-engineering is the practical side of our big cosmic dreams. You can almost think of it like civil engineering or architecture, but, on a planetary scale. It's the literal how-to guide for actually living and working in space.
And the ultimate goal here, well, it's pretty profound. It's not just about surviving out there, it's about thriving. The whole point is to transform these completely alien, incredibly hostile environments, we're talking asteroids, moons, even the vacuum of space itself, into actual, viable outposts that can support human life and industry for generations to come.
Okay, so now that we have the what and the why pretty much nailed down, the next big question is where, right? Where do we even start building? Let's take a look at the prime real estate that the space developers of the future are seriously considering.
Our source material really points to three main spots, each with its own incredible set of challenges and opportunities. We're looking at habitats orbiting the Earth, permanent bases on our own moon, and industrial operations way out on asteroids. Each one of these would be a massive, massive leap forward for us.
First up, orbital habitats. And no, we're not just talking about another International Space Station. I want you to imagine huge, rotating structures that could house entire communities. We're talking self-sustaining cities, complete with their own artificial gravity, just floating right there in orbit. It would be our first true step off-world, a critical outpost right on our cosmic doorstep.
Next up, the moon. And this is about so much more than just leaving a few footprints this time. A permanent base on the moon, a real foothold, would be an absolutely crucial stepping stone to the rest of the solar system. It's a science lab, it's a resource hub where we can mine for things like water ice, and it's the perfect training ground for getting us ready for Mars and beyond.
And finally, we have asteroid mining. Now this is like the gold rush and the Industrial Revolution all rolled into one, but for space. These asteroids, they're like time capsules from the birth of our solar system, and they are packed with valuable stuff. From water we can turn into rocket fuel, to precious metals that are super rare here on Earth. Tapping into these resources is the key to building a truly self-sufficient economy off-world.
So we have this incredible vision. We have these amazing potential locations. But, a vision is kind of worthless without a practical plan. How do we actually build any of this stuff? Well, this is where we get into the how, and it brings us to the engineer's toolkit and the absolutely colossal challenges they have to overcome.
And let's not sugarcoat this. As the source material makes perfectly clear, we are facing colossal engineering challenges. Everything is harder in space. You've got hard vacuum, constant radiation, temperature swings of hundreds of degrees. It forces a completely new way of thinking about construction. Every single part has to be basically failure-proof.
So to tackle these challenges, engineers are really zeroing in on three fundamental pillars. And you shouldn't think of these as separate steps, but more like the interlocking cornerstones for our entire future in space. The stuff we build with, the robots that actually do the building, and the power systems that keep the whole thing running.
Okay, first let's talk about materials. We can't just ship steel girders from Earth, it would cost a fortune. So we have to invent and perfect brand new materials. We're talking about super lightweight, incredibly strong, radiation-proof alloys. Or, and this is the really cool part, things like self-healing composites, smart materials that can literally fix themselves after getting hit by a tiny meteoroid. The ultimate goal, though? Making building materials right there on the moon or an asteroid.
Second pillar, robotics. Sending human construction workers out into the vacuum of space to weld beams. It's not just insanely dangerous, it's pretty much impossible on a large scale. The only way this works is by deploying a massive workforce of autonomous robots. Just imagine swarms of 3D printing bots building foundations on the moon, or spider-like machines assembling structures in zero-G, all coordinated by AI. They are the real construction crew of the future.
And the third pillar, energy. Absolutely none of this works without a constant, reliable source of power. It's a total non-starter. So we need to develop incredibly robust systems. We're talking advanced solar tech, sure, but for places like the lunar poles or deep space, the answer is probably going to be next-generation nuclear reactors. Small, compact units that can provide a steady stream of power for decades, keeping the lights on and the air breathable, millions of miles from home.
So, when you start to put all these pieces together, the amazing locations, the revolutionary materials, the armies of robots, the endless power sources, you really start to see the grand blueprint take shape. It's a future that's not just being dreamed of, but one that is being literally built piece by piece, written in the stars by human ingenuity.
And this, right here, this really gets to the heart of it all. The crucial point isn't about any one moon base or a single mining operation. It's about building an entire ecosystem, an intricate, interconnected infrastructure, supply chains, power grids, communication networks. That's what will finally allow humanity to become a true spacefaring civilization. Every single piece has to work together perfectly.
So the plans, they're not science fiction anymore. These colossal engineering problems are being solved in labs around the world as we speak. The blueprint for our future is right there on the table. So the only real question left is, are we, as a species, ready to pick up those tools and start building?